Hi everyone, this is Julian Verdeguet. I'm CEO at skiplabs, and today I'm going to show you what we've been up to at skiplabs for the last few months. So we already released a database called skdb, which you can find more information at skdb.io with documentation and everything. But what we've built now is a distributed multi-user version of this database. And that's what I want to demo today. So let's get started. First, we're going to start a server, and this server will be listening on port 3048. Everything goes through WebSockets, and our clients work with any client that can run JavaScript. So in this case, I'm going to be running Node, but you don't have to. You can run it directly from a browser. Anything that can run WebAssembly should work. So let's get started. And so here I have a JS prompt, so I'm going to write JavaScript in there. And I have an object that's defined that's called skdb. And so skdb is an SQL database that runs in a browser. So if you want to use it as a database that isn't, connected to anything, you can do that. But I'm going to show you that you can do things that are a lot more interesting once you connect the database to the server. So let's do that together. The first step is to connect our skdb database to our local server. So I'm going to use a WebSocket. The address is a local address because the server is local. I'm on port 3048, and I'm going to ask to connect to the database called test.db. And I want to connect as Julian V, which would be me. And my password is passJulianV, which is not super secure, but it's just for the demo, obviously. So now I'm connected. And instead of sending queries to the server, what I'm going to do instead is I'm going to mirror data that is on the server. So I'm going to import tables from the server, and those tables are going to be kept in sync. So let's do it together. Here, the server takes a parameter because there can be multiple servers. So here, if you have 23 connections, you could say server 23. In our case, there's just one, so we're just going to leave that empty. So I'm going to mirror the table called posts, which includes all the posts that are made by all the different users. So that's working, and once this, after this, I now have access to the post table locally. So instead of talking to the client, I'll be talking to the server. Instead of talking to the server, I'll be talking to the client. So here I am running the request that just run a classic select, and you can see I've got two results, two rows. So you can work with this form if you want to. This would be the typical output from a database, but parsing this kind of output can be a little bit painful in JavaScript. So I recommend you use the SQL function, which will give you back JavaScript objects directly, which is just much more convenient to work. So what do we see in these posts? Well, we have an ID, not very surprising. We have some text that says that this is my first post for skiplabs employees, and a second post that says this is my first post for my friends. Okay, well, that's cool. Now, what I want to show you is what's going to happen if multiple users are involved in working on the same data. So I'm going to open a different tab. I'm going to run skdb.js again. And this time, I'm going to connect as someone else. So instead of myself, I'm going to connect as Daniel L, who is another user in the system. And the password is also Daniel L. Great. So this is working. Now, let's do the same thing and mirror the table posts as such. And let's run a select on it here. Okay, well, first thing that's surprising is that this user is seeing different things. There's still the post called My First Post for skiplabs employees. But then there's another post, which we haven't seen on the other side, which is called My First Post for employees based in France. And you can see that the post that we had here, My First Post for my friends, is missing. So Daniel cannot see this post. So why is that? The reason is this number here. This number is the number that gives access, that decides who can see that row. In this case, it's access number 238, and we're going to look together what that actually means. So let's mirror another table called all access, which gives a summary of all the different access codes that are available in this system. So here it says that 239, which is the one that we used for My First Post with my friends, allows the readers to be the whitelist of Julian V friends and the writers to be Julian V, whitelist Julian V. So what this means is that whenever you see a row with access ID 238, here skdb access set to 238, that means that the readers, the people who will be able to see this row, will have to be members of whitelist Julian V friends, and the writers will have to be whitelist Julian V. So in this case, that's only myself. So what exactly is whitelist Julian V friends? Well, whitelist Julian V friends is in fact a query. So we can have a look at this query by running something on the server, and I'm going to run this command because I have the admin password 1234. And so if we have a peek at what this whitelist Julian V friends means, we can do that with dump view and the name of the view, the virtual view that I'd like to see. And it is asynchronous, so we need something like that. And so here we can see that this is the definition of whitelist Julian V friends. And in a nutshell, what it does is that it selects the friend ID and the access ID from a table called friends, where the name of the friends was Julian V. So what it does basically is that it selects it filters the friends of Julian V in a table called friends. So that's what whitelist Julian V friends stand for. Okay, so now let's have a look at this friend table. If my memory serves well, it is actually empty. Okay, and so if I do a select on my friend list, it is empty. So now what I want to do is add Daniel as a friend. So to do that, I first need to know what the ID of Daniel is. So we're going to have a look at the profiles table to figure this out. And then once the profile ID of Daniel is 64. So I'm going to add our friendship in the friends table. So skdb.client.sql insert into friends local values. So 60, that's me. I want to be friends with 64. And I want to use a permission called -1, which means that everybody can see. And that means everybody in the system will be able to see that we're friends, or that at least Daniel is my friend, not the other way around, at least not for now. So here you can see that instead of modifying the table friends directly, I modified the table friends local. And that's because you never want to modify the table directly. You first have to import the objects that you want to modify in a local version of the table. So for every table that you mirror, there is a local version called the name of the table _ local. And that's what you want to modify when you want to modify something across the wire. So in this case, let's add friend Daniel as my friend. And when I do that, what's interesting is what happened on Daniel's side. If Daniel tries to get to see his posts, he can see the post that I made that was for my friends, because now he is part of my friend list. Now, what's important here is that all of this happened across the wire. So all the changes propagated across the wire. So here, when I make a change on this side, and let's now remove him as a friend again. So if I delete him here, he will stop seeing it on this side. So it happens to be on the same machine, but if Daniel was on a different machine, it would propagate also. So let's add him back as a friend and note a couple of things here. When I press enter on this side here, the system does what's called an optimistic update. So everything that will depend on this value locally will first be updated locally without waiting for the network. And the reason why this is important is that this query here, this insert that you're running, does not wait on the network. So everything that you do will be running locally and will not affect the latency that you have on this client. Now, of course, on Daniel's end, Daniel has to wait for the network to get this post, but Daniel will not be stuck waiting for updates. So the database is still available for Daniel before the my post here arrives, before this post arrived. Finally, you can see if an update has been taken into account by the system, the remote system, and that's by looking into the table called friends global, friends remotes, sorry. So I'm not going to do it here, but basically you have friends local, friends remote, and if you look into friends remote, you will see what has been taken into account by the system, sorry. Okay, so that's cool. The idea is you can define arbitrarily complex privacies, and whenever that privacy changes, that the system will update across the wire. So that's cool. Now let's do something different. Here we have been running queries locally on Daniel's side, but I'd like to do something else and actually subscribe to a query. Because remember, skdb is first and foremost a reactive database. And so what that means is that we can listen to changes on particular posts. So here, for example, I'm subscribing the function, a lambda, to the post table. So I'm going to do this, console.log change detected. So that means that every time something regarding the table posts happened, this lambda is going to be called. So let's try it together and make a new post. So skdb.client.sql, insert into posts local values. So there's the ID of the post, so let's say 30. Then I believe there's the data, which is going to be hello from node. Then there's the owner, which is going to be myself. No, first there's the view, so who can see this, 239, and then there's the owner. Okay, and here you can see that the lambda that we added was called. And so that's going to be true every time we make a new post. So every time we change something, whether it's adding or removing, so here if I make a new post, not only is it going to update the post table on Daniel's side, it's also going to call this lambda every time this post table changed. So here we subscribe to a table, but we don't have to. We can also subscribe to a virtual view. So let's first create a virtual view together. Create virtual view, and we're going to select all the posts from the post table that have the word node in them. And we're going to call this view contains node. Select start from posts where data like, sorry, because I'm using quotes here, percent node percent. Okay. Okay, so now I have a virtual view called contains node. Let's check that it actually works. Great, it works, and they all contain node. And now I'm going to subscribe to this virtual view instead of subscribing to a table. So here I'm going to subscribe to contains node. And I'm going to say change detected in something that contains node. Great, so now I have a lambda, and this lambda is only going to be triggered when I make a post that has the word node in it. So here, let's say I remove node, and I say it's post 32. Only the first lambda was called because the data that it sent did not contain the word node. But now if I add node and say it's the ID 33, I will have the content again. So here I have both lambdas that are going to be called. The first one that we subscribe, that here you can see the text that says change detected, and the second one that we subscribed, that we attached to contains node. So here, of course, we're calling the console, but you could imagine if you were building a live system, you would probably subscribe a lambda that would, for example, update your GUI or something like that. Okay, so now all this works. What does this look like in terms of performance? So let's do it together, and let's add 10,000 entries. And remember that these are separate entries. So for every single one of them, you have a separate transaction, and it would be much faster if we got that all in one transaction. But this would defy the purpose because I'm trying to show you that you can have quite a few transactions sent over the wire. What did I do wrong? Found plus instead. Insert into $i. Is it wrong? Error line 1, expected token. Okay, so let's just forget about that because this is taking too much time. Ah, yes, I'm stupid. I'll figure this out. Okay, so here I'm running 10,000 entries, 10,000 transactions. And if I look on this end, the 10,000 transactions went through. If I look at the data in posts, you will see that it's all there. And the same is true on this end. So okay, hop, let's do a count. And you can see that the database comes back very quickly, even with 10,000 objects. So it's going to work really well, up to hundreds of thousands of objects, and it will really start to slow down after that point. So once you get to million, then it's really going to slow down. So I would recommend to try to stay with tables that are in the tens of thousands or hundreds of thousands. Not that it's not going to work, it's just that it's going to slow down. Now you can mitigate some of those slowdowns by adding an index. So for example, here if I said create index posts, let's call it posts ID on posts ID, that means that every time I try to get out of posts something based on an ID, it's going to be instantaneous because I have the index. And that's also true when the table is really, really large. The index is going to speed things up dramatically. But if you want to run queries that actually need to aggregate or go through the entire table, then obviously as the table grows, it's going to slow down. Now, what I showed you regarding friends and updates for friends still works. So even when there are a lot of entries like here, if I were to change them or remove data from friends or change the access, it will update all those posts very quickly. So here, for example, if I delete friends, if I delete Daniel from my list of friends, friends local, here you can see everything updating, and so I got a notification with the 0 that signifies that this entry was removed. And if I try to look at my posts, well, I'm back to my original 2 posts. And if I add Daniel back, (64 minus 1), you can see that everything is added back very quickly, and I have all my posts here. So that's it for the demo. I hope you enjoyed it, and yeah, we'll have something up and running really soon, and reach out if you want to play with this. We should have something available very soon. Thanks for listening.